Let's write some electron configurations for two positive cations, which means they have lost two electrons to become two positive. Copied and pasted this color-coded periodic table with the blocks color-coded. So iron is number 26. We can write the electron configuration by going back to the nearest noble gas, which is argon. Put that in brackets. And then the remaining, which includes the 4s block, which can hold two electrons, and it's 1, 2, 3, 4, 5, 6. It's the sixth position in the 3D block, so 3d6. Now when we remove electrons, we don't just remove the last one we filled. In other words, we don't remove the last two electrons in the 3D orbital. Rather, we remove from the highest energy orbital first. It's usually your S's before your D's. So we need to remove these two electrons. And what you have left is argon and then 3d6. And so that's your electron configuration for the iron 2+ cation. Let's go on to cobalt, number 27. So again, we'll start with the noble gas before it is argon. And then we still got to make our way through the 4s block. So 4s2. And this time cobalt is in the 7th position. So it's going to end in 3d7. Now when we're removing electrons, remove from the highest and first, not the last. So in other words, this would be incorrect. Okay, that's incorrect. So remove the electrons from the S's, and what you have left is argon, which takes care of the first 18 electrons, and then the remaining 7, which is 3d7. So that is your cobalt 2+ cations electron configuration. Uno más. Nickel. Nickel, right there, number 8. So I think you got this, right? You know you're going to remove the 4s2 electrons, so your answer is simply going to be argon 3d8. And that's for the nickel 2+ cation. So you can see why it's common for transition metals to have a 2+ charge, because it's often going to be easier to remove those 2 electrons in the s orbitals.